Albert Einstein. His name instantly brings to mind wild hair, genius-level intellect, and formulas that forever altered our understanding of reality. Once a patent office clerk, Einstein dared to envision time stretching and space curving. He became the mastermind behind relativity. To Einstein, the universe resembled a flawless machine where every action led to a reaction, and the future could be calculated if you had enough information. Yet as he charted the vastness of space and time, a fresh upheaval was brewing in the minuscule realm of atoms, quantum mechanics. In this domain, the familiar rules collapsed. Suddenly, the universe was blurry, filled with uncertainty and unpredictability. To Einstein, this element of chance felt like a violation of the universe's underlying order. The very scientist who sparked a revolution now stood as the chief doubter of this new scientific wave. The man who inspired us to challenge assumptions began to question the path science was taking. A dramatic confrontation was about to unfold, a legendary struggle for the very heart of physics. What is quantum weirdness? At its heart, the uncertainty principle. Imagine trying to photograph a hummingbird. The flash startles it so you know where it was, but not where it's going. Measure its speed, and its position blurs. For electrons, this isn't just about measurement. Nature itself is uncertain. An electron exists in a cloud of possibilities, not a single place or speed. Only when we measure does it choose a reality, like a spinning coin landing heads or tails. Before measurement, its properties are undecided. This shattered the classical dream of perfect prediction. Reality, at its core, is probabilistic. You can only calculate chances, not certainties. For many, this was a necessary conclusion. For Einstein, it meant the theory was incomplete. He believed a deeper, more orderly truth was still out there. Despite its strangeness, quantum mechanics worked astonishingly well. It explained why atoms don't collapse, how light and matter interact, and powered technologies from lasers to computers. The math was precise, the predictions accurate. Physicists like Niels Bohr and Werner Heisenberg embraced the weirdness, arguing that the quantum world doesn't follow everyday logic. They urged scientists to accept uncertainty as a fundamental feature of reality. Bohr's Copenhagen interpretation claimed that measurement helps create reality. Before that, properties are undefined. The observer became an active participant, not just a bystander. This was a turning point. Physics shifted from certainty to probability. Letting go of Newton's clockwork universe was hard, but quantum theory's success was undeniable. Most physicists accepted the weirdness as truth. For them, the math worked, and that was enough. Einstein couldn't accept a universe ruled by chance. He saw quantum mechanics as a powerful tool, but not the final answer. He believed hidden variables, unknown laws, would restore order beneath the randomness. In a famous letter he wrote, "God does not play dice." For Einstein, God meant the universe's rational order, not a deity. He challenged quantum theory with thought experiments like the EPR paradox, highlighting spooky action at a distance. He argued that particles must have pre-existing properties, not instant connections across space. Einstein fought for a reality that was objective and local, a universe that made sense. Einstein remained quantum theory's greatest critic, even as the world moved on. His hidden variables idea seemed untestable, until John Bell's theorem in the 1960s. Bell showed experiments could decide, was Einstein right, or was quantum weirdness real? Tests in the 1970s and beyond proved Einstein wrong. The universe is as strange as quantum mechanics predicts. Spooky action is real, reality is non-local and probabilistic. Yet Einstein's challenges pushed science forward. His thought experiments inspired the very tests that proved quantum theory's strangest predictions. Today, quantum entanglement powers new technologies. Einstein lost the debate, but his skepticism made us prove the universe's true, astonishing nature.